Hello everybody, I'm Tiziano from OpenDot Lab, and this is the first tutorial we are doing for Custom Orthotics lesson, and that is part of Distributed Design Summer School. The summer school is about design and 3D technologies for healthcare. And the first tool we're gonna use today is Visual SFM, which is the only software I've found to work both on Mac and Windows environment. So it's on this list that it's a pretty comprehensive guide on the best photogrammetry software that are today on the market. We have some free software. I'm looking just off this list because you need to install them for free. And but there is also a lot of really good software for not so much money at the end on some case, and a lot of money on other case. So today we're gonna try Visual SFM, which is a bit difficult to install because it's just a graphical interface for a library which is called Structure for Motion, and it's really used on many software like this. But usually it's run from command line, so it's a bit more difficult to use. With this software, it's just click here, click here, click here, click here, and you're done. So the installing instructions are a bit complex. You need to download the Windows binary or Windows or whatever, Linux, Mac OS, and then go to another website which is on GitHub, and download the binaries of the last tool we're gonna use. If you don't do this passage, you will get just an error while clicking on dense reconstruction, which is actually the model creation. That is still a point cloud, so we will need another step in Meshlab, which I will cover in a separate tutorial just after this. And let's start. So I have already installed it and mixed it with the other binaries for Windows that are here and mixed inside the same folder. You have to follow the proper instruction to do that. And so we will just launch this software. Okay, and it's a pretty simple interface. We just need to load our images here. I have a folder that I'm giving to you with a very small data set that is good for testing this software. I have also a bigger one with much higher resolution images, but will take much more time to do, and for this tutorial it's just enough this. And first step, it's computing matches. You will see anything, and it's really fast. I'm sorry, I need to do another step before this. Okay, so we can stop process here, and first we need to compute missing matches, which is crushed pretty fast. Okay, so we start again. It's really fast to start, so I need to do the things in the right order. So first step here, import the images, open, then compute missing matches. If you have any doubt, you can just go to here, add some image, match the images, sparse reconstruction, dense reconstruction. So it's done, took 1 second, so it's the fastest of all the operation. The next step is making a first matching between the scene. As you can see, starting to compare some dot and putting the images together. These are the camera position. As you can see, it's the same angle from which of these photos were taken. So we can order by. So you can see we started from this side, then this, then this, then this, then this, then lower side this, this, and this. So as you can see here, it's 5 photos with a higher angle and 3 photos with a lower angle, and this is my face. It's not easy to understand, but it's my face. And so next step is to make a bundle adjustment, which will just modify a little the position of the camera, and then we can run the last step, for which we have installed the other library inside. If we didn't do that, you can go up to this point but not got anything while clicking on this button. I need to save my file, so small point cloud, and run it, and we'll make pre-compute the first matches and then make last step that will take just a few minutes. So what the computer is doing, we have already looked in each photos for a point to make a first match between the photos, and then it's doing the alignment of the photos. It's the step we have done before, and now just finished to do the dense reconstruction. We can still see anything because we need to switch from N-view 3D points to dense 3D points. And as you can see, this is a nice point cloud over my face. It's missing some details on the side, but this depends just on the subset I've done of this full data set, which is pretty low in image numbers. So if I had more photos of the side of my face, I should have much more points here, as you will see on the other software. Okay, so right now we can just see in our folder where is the point cloud. So we have a folder with the same name we have said before. Then there is workspace, then 00. Those two files are just the camera alignment. And then we have a folder with models with the dense reconstruction we have done. So I just try to click on this and see if there is something on Meshlab. So this is Meshlab, and this is my face. And a funny thing, this is the back side of my face, which is pretty strange to look at it. Never seen my face from the backside. Okay, I think we are done, and we'll follow a very quick lesson on Meshlab. So stay tuned for the next tutorial. Bye.